So we have a challenge here. What is the area of this shaded region? Notice how we have a circle. So the area of the shaded is pi r squared, which is the area of the entire circle, the large circle, minus pi r squared, which is the little circle, the tiny, tiny little circle here. So what is the large circle, capital R? Capital R is the radius, which starts in the center and goes all the way across, which is x plus 2 more. So it's x plus 2. And what is the little radius? The little radius happens to be x. Now one way of solving this is to expand fully. So let's try. This becomes x squared plus 4x plus 4 minus pi x squared. Let's just expand this fully and see what happens. It's kind of the opposite of factoring, but perhaps we can go back to factoring. So we have pi x squared plus 4 pi x plus 4 pi minus pi x squared. Notice how these pi x squareds cancel out. So all we have now are these two terms. What's the common factor for this? We can pull out a 4 pi, and we have x plus 1, because 4 pi times x is 4 pi x, and 4 pi times 1 is 4 pi. So this here is our fully factored and simplified answer. Now let's try it another way that's good for brain training. So we know that the area of the shaded is pi r squared, the big circle, minus pi r squared. So for practice, let's try to think of the radius squared as x plus 2 minus pi r squared, which happens to be the inner radius, which is x. Let's try factoring out the GCF, pi. Pi is common to both terms. We're going to set up a big bracket here. Pi times what becomes the first term? And we have x plus 2 squared. Now pi times what becomes the second term? We have negative x squared. And now notice how we have difference of squares. If we let a equals x plus 2, we now have this part here being a squared minus x squared. So we can actually factor this as difference of squares, which becomes a plus x, a minus x. So let's do that. We're going to leave this pi alone. Let's set up some big brackets here. And so what we have is a squared minus x squared is going to be a plus x, a minus x. And what is a? A happened to be x plus 2. So we have x plus 2, which is our a value, plus x, and we have our a value, x plus 2 minus x. Now we can clean this up a little bit. X plus x is 2x. So we have 2x plus 2, and x minus x disappears, so we only have 2. Now 2 times pi is 2 pi, and all we have is this part here, but we can factor out a 2. So we have a 2 times x plus 1. When we feed the dog and feed the cat, you can see that distribution creates this, and we're almost done. The last step is to multiply 2 times 2, which is 4 pi x plus 1. So this technique was a bit more abstract, good for brain training, but the previous technique was a bit easier.